Before the video starts, I have a small request. I've launched a second channel called Tour Encyclopedia, where we explore the most fascinating and beautiful places around the world. If you're interested in travel, make sure to check it out and subscribe. The link is in the description below this video. And now, let's dive into the main episode. Boxer. Meet the Boxer. If you like the idea of a military Lego set, where the chassis is your base smartphone and the mission module is an app you just slot in, then Boxer is your iPhone on a wheeled, combat diet. Only instead of running games, it moves troops from point A to point B while keeping them safe from bullets and explosions, sometimes brilliantly, sometimes with a few caveats. The Artec consortium combined European experience with solid engineering discipline and ended up with an 8x8 that can do almost everything and demands almost everything from your logistics department in return. Let's start with the basics. Boxer is a modular vehicle. That's not just a marketing slogan, it literally has two main parts, the drive module and the mission module. The drive module includes the engine, transmission, suspension, and driver's cab. The mission module is a removable box you can swap out: a troop transport, medical unit, command post, engineering platform, air defense module. The idea is brilliantly simple: one universal chassis, dozens of possible roles. Logistics, of course, has mixed feelings. On one hand, you save money because you don't need to buy multiple specialized vehicles. On the other, now you have to track a bunch of interchangeable boxes, their conditions, total weights, and compatibility. Now, let's talk powertrain. Boxer typically uses high-performance diesel engines, often MTU 8V199/8V199 TE20 series or equivalents, paired with Allison or Renk automatic transmissions depending on export or upgraded configurations. Early versions offered around 720 horsepower, but newer variants push beyond that to keep the power-to-weight ratio reasonable as armor packages get heavier. Why so much power? Because modularity means your vehicle's weight can fluctuate dramatically. Add more armor, and your agile 8x8 suddenly feels like it's towing a shopping mall. So yes, Boxer's big engine isn't there for show, it's there to make sure the vehicle can still move after you load it with all your extras. Now for the suspension and driveline, the stage where Boxer really shows off. Full-time 8x8 drive, steerable front, and sometimes rear axles, locking differentials, and advanced suspension systems give this beast maneuverability few wheeled platforms can match. Add to that high ground clearance, large run-flat tires, and a central tire inflation system, CTIS, and you get a vehicle that can crawl through trenches, tear up dirt roads, and cruise down highways. On-road speeds exceeding 100 km per hour are not uncommon. But here's the catch: more armor and heavier mission modules mean more axle load, faster tire wear, and tougher maintenance schedules. Now, protection, briefly, because we'll get deeper into that later. Boxer's base armor provides strong protection against small arms and shell fragments, and with add-on kits, it can resist much more serious threats. The manufacturer and Artec claim STANAG 4569 Level 4 baseline protection, upgradable to levels 5 to 6 on the front arc using AMAP modular armor. In plain terms, you can order frontal armor that shrugs off 30mm rounds, but be prepared to pay the price and extra tons and stress on the drivetrain. Here's the key engineering takeaway: everything is connected. Add a heavier turret, you add mass, shift the center of gravity, and wear out the suspension faster. Upgrade the armor, you increase heat output and cooling demand. Solving one problem usually means upgrading 5 other systems: stronger axles, bigger radiators, reinforced mounts, all of which cost money and make maintenance trickier. And now for some operational honesty. Boxer is excellent if you have A. a reliable logistics network, B. spare modules and drive units, C. trained crews for quick swaps and electronic maintenance. Without those, Boxer is just an expensive armored truck with too many features you can't use. In low-support environments, simpler vehicles often outlive and outperform high-tech ones simply because they can be fixed with a wrench and patience. And finally, a touch of sarcasm: Boxer makes officers happy at exhibitions, engineers proud in factories, and sergeants quietly curse in the motor pool, especially when they have to unload a 15-ton mission module in the mud, during rain, with 2 hours before deployment. But that's normal, because truly advanced machines demand respect, and a lot of maintenance. Boxer is like a Swiss layered armor cake, several layers, each with its own job, and if everything is assembled correctly, people inside stay alive. Let's go step by step. Materials and modular armor. The base structure is a welded steel monocoque, shaped to deflect shape charge jets and distribute impact energy. But the real strength is in the applique systems, modern box panel solutions built from composites, ceramics, and light alloys. In the industry, this is commonly described as the AMAP family, AMAP-B for ballistic protection, AMAP-M for mine protection, AMAP-L for spall liners, etc. These modules let you grow protection for a specific mission, from basic small arms protection up to a reinforced frontal plate that can defeat a 30mm projectile in a given arc. Spall liners, internal liners, are not a fashionable accessory, they are life-saving. They catch fragments of the armor and reduce the lethal spall cone inside the compartment. The simplest difference: without a spall liner, perforated metal plus shrapnel turns the interior into a spray of fragments. With a liner, you get a lot less backblast and the probability of serious injuries drops. Mine protection: classic engineering of shape plus energy absorption. A V-shaped belly, energy-degrading elements, and multi-layer floors are what make Boxer walk-away survivable in many cases. But it's important to remember, mine protection is measured in probabilities, the chance to survive and the ability of the vehicle to continue moving, not a 100% guarantee. Large IEDs and shaped EFPs are a different threat level altogether, and countering them requires different solutions, either specialized MRAP platforms or active protection measures. Blast protection is also achieved through suspended seats and decoupled floors. These reduce the acceleration transmitted to occupants during a blast. Simple idea: don't bolt the soldier rigidly to the hull, give him a shock absorber, his chances of survival improve. ERA and active systems. To defeat shaped charges, you can use explosive reactive armor, ERA, or non-explosive analogs, spacing panels, AMAPP, and new electric reactive concepts, no explosives. ERA gives excellent protection against shaped charges, but explosive ERA can produce dangerous fragments around the vehicle and needs careful use in urban environments. Active protection systems, APS, Trophy, Iron Fist, etc. intercept threats in flight, but they add weight, electrical load, and operational complexity, interference, rules of engagement, maintenance. Boxer supports integration of such systems, but that is a separate budgetary and logistical project. Moving to the running gear, where practical mobility lives. Suspension and axles. Boxer is designed as a serious full-drive 8x8, steerable axles, lockable differentials, and a modern suspension tuned for the balance between cross-country mobility and payload. There are variants with independent suspension or semi-independent setups depending on the version and customer requirements. The core point: the suspension must withstand large vertical and lateral loads when extra armor and turrets are fitted. If you don't reinforce it when you uparm the vehicle, you'll soon see failures, suspension bottoming, broken mounts, and frequent breakdowns. Axles and gearboxes. For heavy configurations, hub reduction axles with planetary gears are often used. These reduce torque loads on the drivetrain and help preserve ground clearance. But such hubs are more expensive to repair and heavier. Another point: reinforced axles and gearboxes need proper cooling and scheduled maintenance, otherwise any serious operation in mud and water turns into a major service event. Tires, CTIS, and run flat. A central tire inflation system, CTIS, plus run flat inserts is a must. Boxer must keep moving with a punctured tire. However, low pressure for mud increases sidewall load, and long runs on run flat inserts burn out their service life. Spare tires and practice tire change procedures are vital. New tires with reinforced sidewalls and beadlock solutions improve payload capability, but they're expensive. Brakes and steering. Boxer uses multi-disc brakes with ABS and supplemental retarders, or hydrodynamic retarders, to control mass on descents. On heavy vehicles, brakes are a common point of failure under overload. Regular inspection of pads, discs and brake cooling systems is mandatory. Steering is hydraulic with electronic assists. When the center of gravity shifts, steering characteristics change and the driver must feel and compensate for that. Cooling and power supply. Adding armor and turrets increases load on the electrical system and heat generation. Generators, battery packs, distributed power buses, extra radiators, and fans all are required to keep EO/IR, radars, APS, and other electronics operational. Many variants also include an APU, auxiliary diesel generator, useful for surveillance at night without running the main engine. Without adequate heat rejection, optics and electronics degrade, sensors overheat and accuracy drops. Practical consequences of these upgrades. The more armor and features you add, the more you must consider: strengthening suspension and axles, increasing engine power, upgrading brakes, stocking spare parts, tires, axles, drives, fuel logistics. Consumption will rise significantly. Strategic air transportability. Some heavy configurations no longer fit a C-130, you need an A400M or dedicated logistics. Bridge/road certifications and transport restrictions. Mass matters. And finally, maintenance. Boxer's modularity is a great blessing as long as you have a workshop, lifting equipment, and a module depot. In the field, replacing AMAP panels or hub gearboxes takes time and qualified personnel. If wars are decided not by who shoots better but by who recovers kit faster, Boxer wins, provided you have mature support. Without that support, it is painfully vulnerable. When you add weapons, sensors, and comms to the Boxer, it stops being just an armored truck and becomes a combat node. That transformation, however, is expensive, power-hungry, and sometimes fussy. Here I go into detail about turrets, fire systems, fire control, sensors, C4I integration, and how all of this affects tactics, armament, and firepower. Boxer was designed as a platform able to carry light RWS, remote weapon stations, in the 7.62 to 12.7 mm class, full-size combat modules with a 30 mm cannon, for example Lance/Rainmetal type modules, and even specialized air defense and artillery kits. The differences in mass and recoil are huge, and RWS is almost plug-and-play. A 30 mm station is an engineering project. Installing a 30 mm module requires calculating the firing moment, reinforcing longitudinals and mountings, possibly adding stabilizers, and balancing the ammunition load. Autonomous combat modules with autoloaders reduce troop space but increase rate of fire and autonomy. Stabilization and FCS. A modern gun without 3-axis stabilization and a ballistic computer is just an expensive way to damage a turret. In combat configurations, Boxer uses stabilized turrets with integrated EO/IR, a laser rangefinder, and ballistics. This gives real ability to fire accurately on the move and to execute hunter-killer tactics. But there are two caveats. 1. The quality of EO/IR and ballistics algorithms is critical. Cheap sensors and poor calibration negate all advantages. And 2. The system needs stable power and cooling, again a load on the vehicle's electrical and logistics systems. Ammunition and storage. Every extra round is mass and volume. 30 mm rounds are heavy, they must be stored safely, fed to the turret reliably, and protected against sympathetic detonation. Smart solutions, blast-proof containers, segregated storage, and blowout panels save lives. But reserved troop space shrinks, and total vehicle mass often grows faster than the original specification anticipated. Sensors, the vehicle's eyes and ears. EO/IR electro-optical packages, day/night, laser rangefinders, and thermal imagers are standard. Boxer is often fitted with additional sensors, 360 degrees cameras, acoustic shot detection systems, short-range LiDAR/radar for drone detection, and signals intelligence/RF sensors. The combination gives the commander a near real-time picture of the battlefield. However, more sensors mean more interfaces, more software, and a greater need for personnel to analyze the data. And again, power and cooling. APS and soft kill. The option to fit active protection systems, APS, and soft kill suites, rocket/laser dazzlers, smoke generators, EW, is a serious plus for survivability. APS can intercept ATGMs and RPGs in flight, but they require space, mass, and electricity, and they raise political and legal issues in urban use. ERA fragments or APS detonations can injure nearby infantry. Soft kill systems are simpler and cheaper but less universally effective. Integrating APS on Boxer is possible, but it's a separate budgetary and maintenance project. C4I and networking. Boxer often operates as a node in a BMS, battle management system. It receives data from drones, streams EO/IR video, accepts target designations, and shares friendly positions. This changes tactics. The vehicle becomes not just a weapons carrier but a sensor platform and relay. High-speed protected data links, encryption, and redundancy are mandatory. Experience shows, it's better to have a medium armor package and excellent comms than top-end armor and a blind vehicle. Information often decides the outcome faster than armor. Tactical roles and employment. Boxer is flexible. As an IFV it provides fire support and carries troops. As an APC it delivers infantry under protection. As a command module it coordinates operations. As an air defense variant, Skyranger, it fights aerial threats. As a medical module it evacuates casualties. This gives an army unified logistics and rotation flexibility. On the battlefield Boxer excels in strike and maneuver tactics, use mobility, reconnaissance and the network, hit quickly and withdraw. Operational lessons and real cases. User experience shows, people survived. In IED/mine hits Boxer frequently preserved a survivable volume, the structure and spall liners worked. That is the primary KPI. Logistics decides everything. Without spare drive modules, AMAP panel stocks and modular swap skills, Boxer quickly loses combat readiness. Networks and sensors are a decisive advantage. Vehicles with good BMS and integrated sensors operate more effectively and flexibly. APS and EW are becoming standard in modern theaters. Lacking these options reduces survival chances against contemporary threats. Criticism and the things that eventually irritate. Cost, Boxer is not cheap, and the price of modules is a recurring budgetary surprise. Complexity, the more options you add, the more failure points appear. Scalability of protection leads to a mass threshold problem. Sooner or later you need a new power pack, and then drivetrain adaptation follows. Human factor, crews and technicians servicing FCS, APS, and BMS must be highly skilled. That takes long training. And finally, cyber vulnerability. The network is a strength but also a potential weakness. Software and comms must be hardened. Tactics in short, Boxer is not a tank. Its strength is mobile protection, fire support and information. Use it in concert with reconnaissance, air support and logistics. Do not park it static on the front line alone against heavy guns. And don't be surprised if in the wrong hands the modularity turns the vehicle into a pretty but useless collection of unnecessary options. So, let's sum it up and look at the Boxer through the lens of the tasks it actually excels at, and those where it's not exactly the king of the hill. Tactics and concept of use. Boxer is the embodiment of subtle strength and smart power. Its ideal role is providing mobility and protection in maneuver warfare, raids, patrols in IE de-risk zones, convoy escort, rapid infantry rotation, and tactical group support with networked intel. In the right combination, reconnaissance, strike, withdrawal, Boxer plays both brain and shield. It carries combat modules, collects data, relays commands, and safely extracts people. It shines as a platform for integrated strike groups where information itself becomes an extra layer of armor. Logistics, the key to success. Let's repeat it, because it's the pain point for many modern platforms. Boxer only wins when logistics are strong. You need spare drive modules and the ability to swap them quickly, a mission module depot and a rotation plan, spare AMAP armor panels, chassis parts, axles, and special equipment, trained crews for FCS, APS, and BMS systems, and proper transport infrastructure, at 400M/and 124/rail platforms, for strategic mobility. If any of these components are missing, Boxer quickly becomes just a very expensive parking ornament. Comparison with major competitors. Without diving into every detail, here are the key points when comparing Boxer to other 8x8 and IFV platforms we've mentioned before. Against JLTV and American light vehicles, JLTV is lighter in logistics and cheaper to maintain under friendly US conditions. Boxer offers far better protection and modularity but costs more and demands stronger support. If you need mass mobility with a minimal logistics tail, JLTV wins. If you need modularity and protection, Boxer is your pick. Against Mowide Piranha and other 8x8s, Boxer is highly competitive. Piranha and similar platforms are mature systems with well-developed ecosystems. The main difference, Boxer's modular architecture and its focus on quick mission reconfiguration. Depending on the variant, Piranha can be more economical in operation for some users. Against tracked IFVs, Abrams/M2/Bradley class not really comparable. Tracked platforms offer better off-road armor survivability and can push through with heavier support under fire. Boxer's strengths are mobility, flexibility, and lower cost per kilometer. If you want a breakthrough IFV with tank-like armor, go tracked. If you want a distributed, fast replaceable armored carrier, Boxer's your guy. If you're considering Boxer for your army, think carefully through these points. 1. Define missions clearly. Do you need mass mobility for patrols, or will Boxer serve as an air defense/artillery/medical hub? The configuration must match the task. 2. Budget beyond purchase. Plan for the ecosystem. You'll need as many modules and spare parts as missions. Without them, Boxer is just an expensive cart. 3. Training and support. Invest in crew and technician training and mobile workshops. Modules require skilled hands for quick and proper swaps. 4. Transport logistics and specs. Check whether your desired configuration fits your strategic transport options. If not, add shipping costs and maintenance intervals. 5. Network integration. Don't skimp on C4I. Good networking makes the Boxer several times more effective. Bad networking makes it twice as costly and half as useful. Final honest verdict: strengths and weaknesses. Strengths: scalable protection, modular architecture, excellent mobility for an 8x8, high versatility for combat and support roles, and solid industrial backing. Weaknesses: cost, maintenance complexity, dependency on available modules and spares, weight growth with armor upgrades, and the constant need for strong power in systems. Boxer is like a pretentious Swiss Army knife. It's got a big blade, a bottle opener, a tiny file, and a couple of tools no one ever uses, but they look fantastic in the brochure. In skilled hands, that knife can save your life. In clumsy ones, you'll just cut yourself and spend an hour figuring out how to fold all the tools back in. And yes, if you want everything at once without proper support, think twice. Maybe start with something simpler and scale up gradually. Boxer is a platform of the future built for today, flexible, protected, and able to evolve with the threats. But it's not a buy and forget system. It's a long-term project involving logistics, supply chains, drills, and mechanic salaries. If you're ready to invest in support, training, and infrastructure, Boxer will pay you back in real combat flexibility and protection. If you just want to set it and forget it, pick something simpler and cheaper to maintain. Boxer is both an engineering masterpiece and a logistical challenge. It loves attention, a warm maintenance bay, and careful hands. Give it that, and it will serve faithfully. Neglect it, and it will remind you of the price of modularity in the most unpleasant way possible, by breaking down in the field. Thank you for watching.